Okay, welcome back everyone. Just to finish off that question, here we were. Okay, so we're going to find mu, the coefficient of friction, and we're going to need to resolve. Well, you can resolve in any two directions, providing they're not parallel directions, that is. Normally in these questions, it tends to be either horizontal and vertical, or perpendicular and parallel to a slope, or to the rod like this. In this case, well, you've got two perpendicular forces, one horizontal force, and this one N, which is perpendicular to the rod, so it's neither horizontal or vertical. Well, it would seem that three forces are vertical and horizontal, so vertical and horizontal, it would be the way to go. So let's start with vertical. I'll go resolving. There we go. Resolving vertically. So we'll go up. We have R, and we have the weight minus, because that's down, 40G, sorry. And then F is horizontal, so nothing from that. And then we have the N. Well, N has components. N is neither horizontal or vertical, so we need to find the horizontal and vertical components. We've got 15 degrees here. So if I were to just draw a vertical line there, that's 15 degrees. So this angle in here is also 15 degrees. We know that. Why is that? Well, this angle there would be 75 degrees. And therefore that is 15. And therefore that is 15. And so the vertical component would be the adjacent, the cosine. That would be N. And it would be plus, because it would be up, N cosine 15 degrees. And that equals 0, because it's in equilibrium. So R equals 40 times 9.8 minus N, which we know is 237, times cos 15 degrees, and that equals 163.41 newtons. To find F, we would resolve horizontally, so we have F. Now R and 40G are vertical, so we have just the component of the reaction N, and that would be N sine 15 degrees, and it would be going the other way. So minus M sine 15 degrees equals 0, because we have equilibrium. So F equals N, which is 236 or 237 times sine 15 degrees, and that comes to about 61.25 newtons. And then the last thing to do is to find mu. Well, from limiting equilibrium, I could write this here. When you setting out these problems, you see down the left hand side here I have the instructions or the reasons where the equations come from. This is the principle by which I create the equation. Moments, resolving, limiting equilibrium, that gives me F equals mu R. And then for each one of these we have an equation, and then we solve the equation. That's the correct way to set out the problems. So F equals mu R, 61.25 equals mu times 163.41, which gives a value of mu as 0.37 to 2 decimal places. Okay, now could you pause the video and have a go at this question yourself, and I'd like you to write it out neatly, scan it, and save it as a PDF, and I'm going to create an assignment of where you can submit it to me and I can have a look at it for feedback and give you feedback. Okay, so pause the video. When I stop the video, I will put the notes into that assignment, and I will put this question on those notes so you'll be able to read it. Okay.